This PowerPoint, we're going to look at the answers to your Period 1, Period 2 lesson on fireworks and flame colours. Please do watch all of it, and please do write in your corrections or anything you need to help you learn. So you should have written the date, the keywords, the title, the keywords, and then the starter after, and all of that should have taken you around 10 minutes. So today's lesson we're looking at how can we make fireworks different colours, and you'll be able to answer that at the end of the lesson, hopefully. Your keywords are oxidation, which is the addition of oxygen, which you've already come across. Exothermic just is a reaction which releases heat energy. So here it's probably combustion reactions are exothermic, but oxidation reactions aren't always exothermic, but combustion reactions are. Splints, they're the wooden sticks that you use to light a Bunsen burner, and we'll be using flame tests. We'll be using splints in flame tests. Metal solutions, flame tests, we'll be doing those later and looking at those later, and platinum or nichrome wire. Nichrome is just a mixture of nickel and chromium metals. And it's what we call an alloy when we mix two metals together, and they have special properties there. So you can see here there's three different oxidation reactions here. Your first one here is your copper coin, and that's been oxidized to copper oxide. You can see that there's some blue or green tinges here. And then you've got your matches here, which are being oxidized. And this is a combustion reaction, so it's reacting with the oxygen in the air. And here, this is your metal tarnishing. So your metal, I think this is pewter, which is a type of old metal, and that's been oxidized to a metal oxide. And we'll look at these a bit in a moment. So your starter here would have been to sort all of these labels out into this table, whether they're oxidation or combustion only. Now these are your answers: your food spoiling, rusting, respiration, metals tarnishing. They're oxidation only. Remember, the combustion reactions are oxidation, but they just release heat and light energy. So please do write your corrections in or correct your table, so you have a correct table or set of answers in your book. Now you should have written these sentences in red. Now this reaction here, your metal plus oxygen equals metal oxide, we'll be looking more at these reactions throughout the slides. Here's an example of it. In your combustion reaction, as you know, light and heat is given off in an oxidation reaction. We call that combustion. So again, you should have written out the sentences in red, and here we've got oxidation is when oxygen is being added to a substance. Light and heat energy are given off in a combustion reaction. Here's your flares, that's a combustion reaction in your sparklers, and heat energy is being produced in an exothermic reaction. And there are other reactions which are exothermic, but combustion is the most obvious because you get lots of heat and you get light as well. So these are the flame colours for each of these different metals. And you should have written down the two notes as well. That just explains that not all metals actually give off characteristic flame colours when you put them in a blue flame. Only some. So iron, for example, doesn't give a characteristic colour. So you can't test for iron using the flame test. All of these colours you can. I've added barium in here, and that's just because it was in the video, but barium is also, all these metals can also be used in fireworks to give the fireworks the characteristic colours. And that links back to your question, your title question. Now this poster contained, in your period 2 lesson, this poster contained all the information that you needed to answer the questions on the following page, and it grouped them into different parts or components of your sparkler and your metal fuels. You've got aluminium, magnesium, iron, or titanium or ferrotitanium, and you can see that they actually give as well as your colorants, they actually give the sparkler different colors. So iron gives a gold sparkler color, titanium gives a silver, titanium is like a yellowy color, and then your aluminium and magnesium mix, that gives like a kind of a pale yellow color. These are your three nitrates, your three oxidizers, nitrate, chlorate and perchlorate. And your binder, we can holds the mixture together. Dextrin is a common one, and then here are some of your colorants. And you've done your flame test here, so you'll know a bit about some metal ions which give colors and their characteristic colors. Barium is green, copper is blue, and calcium is orange, and sodium is yellow. Strontium is red or crimson. So these were your metallic fuels, and as you can remember, the metallic fuels also give like the sparkler a different color, which is different to the colorants. The colorants give it like more bright, vivid colors, like fireworks or sparklers, bright, vivid colors. But your metallic fuels, if there are no colorants, can give it just a nice like gold or silver like color. Your aluminium. So your oxidation reactions for each of these metallic fuels are below, and they're all just metal oxides. Be careful because you do have to change the name, the ending to "ide," which I'm just kind of circling for you there. Your oxidizers: chlorate, nitrate, and perchlorate. And the function of the oxidizer is to provide the oxygen for combustion. Sometimes it's just not enough in the air. And because there's not enough in the air, you don't want to have to keep wafting it around. So sometimes it just helps the combustion reaction there. Your binding agent is dextrin. There are some other binders. You'll see another binder in the factory tour. So binders are just used to hold the mixture together, the slurry, the metals, oxidizing agent, and colorants together. And these are your colorants. And these are the colors of the colorants as well, the colors that they give. And that's what colorants do. So I hope you enjoyed the factory tour. We'll go through some of the answers now. The barium nitrate was the oxidizer that was used, and it provides more oxygen for the combustion reaction. Sometimes the oxygen in the air isn't enough. Boric acid was used to neutralize the slurry mixture, and that's just so when the sparkler is being used and some of the slurry melts, it may melt. It doesn't. It's not corrosive. Water and cornstarch were the binding agents that bind everything together in the slurry mixture. The iron was the metal that was added to give the gold color. They didn't add any further colorants to get any different colors. Just iron for the gold. The metallic fuel that was used was aluminium powder. So aluminium plus oxygen reacts to form aluminium oxide in this combustion reaction. And that lets out lots of light and heat. The name of the mixture was slurry, and your ions, your sticks, your sparklers were dipped twice in slurry and taken around an oven after to be dry. So the flame test is something that you're actually required to know at GCSE level, but I think it's good to know it for Key Stage 3 as well. So in GCSE, you'll be required to state how to carry out a flame test, and it could be a 2 to 3 mark question in an exam. So the first mark you'll get for saying dip a clean nichrome or platinum wire loop into a solid sample. Now, it could be nichrome or platinum. If you remember, nichrome is just a mixture of nickel and chromium, and it has to be one of these two metals just because they are unreactive, so they don't react with the sample. They have a high melting point, so they don't melt when you carry out the flame test, and they don't produce a color. So there's 3 reasons why we use nichrome and platinum wire. And again, a question at GCSE could ask you that, but you don't need to know it at this stage. Then you can put the loop with your sample on it into the edge of a blue flame. It has to be blue, so you can see the color clearly. And then observe and record the flame, the color of the flame produced.